Hello dear students, how are you all? Myself Sunil Mishra, and today we are going to start one of the most interesting chapter of grade 10th mathematics, and today you have to guess the name of this chapter. So here we have a mountain. Let's suppose you want to measure the height of this mountain. You don't have any modern navigation instruments. So how you are going to measure the height of this mountain? Let's guess. You can take your time. Okay, let me tell you, don't worry. So the height of this mountain you can measure using trigonometry. In fact, the height of the tallest peak in the world, that is Mount Everest, is measured by Britishers under British Survey of India. And what is the height of Mount Everest? Do you know? It is 8,848 meter. And do you know the person who measured the height of this mountain using trigonometry? He was Radhanath Sigdar, and he was working on the post of computer under British Survey of India. So today we'll start chapter Introduction to Trigonometry. So without much ado, let's get started. Okay, so this is chapter number 8, Introduction to Trigonometry. So let's talk about practical applications of trigonometry. It is used in navigation, construction, astronomy, and it has many other important applications. Okay, let us understand the meaning of this word trigonometry. So the word trigonometry is made up of three Greek words, tri, gon, and metron. So tri means 3 and gon means sides and metron means measurement. So trigonometry is a branch of mathematics that gives the relationship between the sides and the angles of a triangle. Okay dear students, do you know who is the father of trigonometry? This is Hipparchus. He is a Hipparchus. So Hipparchus of Nicaea, Greece is considered as the father of trigonometry. He is the first person who started trigonometry. So before starting trigonometry, you should know about Pythagoras theorem. This is very important theorem that gives the relationship between the sides of a right angle triangle. So what is Pythagoras theorem? You already know. So let's revise it. In a right angle triangle, the side opposite to right angle is called hypotenuse, and in a right angle triangle the square of hypotenuse is equal to the sum of square of other two sides, that means base square and perpendicular square. So what is base here? Base is the side which is adjacent to theta. Okay, so this side is base because hypotenuse is always fixed. Hypotenuse is the side opposite to right angle, and the side which is adjacent to theta will be base, and the side which is opposite to theta will be the perpendicular. So this is our perpendicular. So in a right angle triangle, the square of hypotenuse is equal to sum of square of other two sides. That means hypotenuse square is equal to perpendicular square plus base square. Now we will find trigonometric ratios of an acute angle in case of a right angle triangle. So here we have a right angle triangle ABC. So I am giving the names to the sides of this right angle triangle. Let us suppose this is X and this is Y and this is R. Base is X, base is the side which is adjacent to theta. Perpendicular is Y, perpendicular is side opposite to theta, and our hypotenuse is R. Hypotenuse is always side opposite to right angle. Now we will find the trigonometric ratios of this right angle triangle. Okay, trigonometric ratios is nothing but the ratios of the sides of this triangle, and will relate the ratio to the angle theta. So before learning this trigonometric ratios, you should know about one magical mantra, that is Pandit Badri Prasad Har Har Bole. Okay, and he said, what he said? He said Sona Chandi Tole and Chai Samose Chole. Okay, so let me tell you what is this. The first trigonometric ratio, the name of first trigonometric ratio is sine theta. And sine theta is the ratio of perpendicular and hypotenuse. So sine theta is the ratio of perpendicular and hypotenuse. Perpendicular is side opposite to theta, that means Y, and hypotenuse is always side opposite to right angle, that means R. The second trigonometric ratio is cos theta, which is the ratio of base and hypotenuse. So cos theta is the ratio of base and hypotenuse. Base is side adjacent to theta, which is X, and hypotenuse is always the side opposite to right angle, that means R. Now third trigonometric ratio is tan theta. So tan theta is the ratio of perpendicular and base. Perpendicular is side opposite to theta, that means y, and base is x. Now the fourth trigonometric ratio is cosec theta. So cosec theta is the ratio of hypotenuse and perpendicular. Now we will take in the reverse order. Hypotenuse and perpendicular. So hypotenuse is the side opposite to right angle, that means r, and perpendicular is side opposite to theta, that means y. Now fifth trigonometric ratio is sec theta. So sec theta is the ratio of hypotenuse and base. So hypotenuse is the side opposite to right angle and base is x. The last trigonometric ratio is cot theta. So cot theta is the ratio of base and perpendicular, base upon perpendicular. Okay, so base is the side adjacent to theta, that means x, and perpendicular is always the side opposite to right angle, that means y. So here we have all 6 trigonometric ratios. Now here we can notice the value of sine theta and the value of cosec theta. The value of sine theta is y upon r and the value of cosec theta is r upon y. Here you can clearly notice that there is a reciprocal relationship between sine theta and cosec theta. You can write here sine theta is nothing but inverse of cosec theta. And again, if you look the value of cos theta, which is x upon r, and the value of sec theta is r upon x. So these values are reciprocal of each other. So here we have the reciprocal relationship between cos and sec. So we can write here cos theta is nothing but inverse of sec theta. At last here we have tan theta. So value of tan theta is y upon x and the value of cot theta is x upon y. That means these values are reciprocal of each other. Again you can write here tan theta is nothing but inverse of cot theta. Let's see what we will get if we divide the value of sine theta and cos theta. What happens if we divide these two equations? That means sine theta upon cos theta. The value of sine theta is y upon r and the value of cos theta is x upon r. And what will happen? This r and r will be cancelled out and we'll get sine theta upon cos theta is equal to y upon x, and the y upon x is the value of tan theta. So we can write that tan theta is nothing but the ratio of sine theta and cos theta. Similarly, we can write that cot theta is the ratio of cos theta and sine theta. So we can express tan theta in terms of sine and cos. Okay, and we can express cot theta as a ratio of cos and sine. So let's understand law of sines and cosines. So law of sines and cosines can be applicable to any kind of triangle. So here we have a triangle ABC. The side opposite to angle A is represented by small a, and the side opposite to angle C is represented by small c, and the side opposite to angle B is represented by small b. Okay, so what is law of sine? So according to law of sine, sine of angle A upon side A is equal to sine of angle B upon side B is equal to sine of angle C upon side C, and this is fixed. Okay, this is constant. And what is the law of cosines? So according to law of cosine, cos of angle A is equal to B square plus C square minus A square upon 2BC, and cos B is equal to A square plus C square minus B square upon 2AC, and cos of angle C is equal to A square plus B square minus C square upon 2AB. So these are law of sines and cosines. These law of sines and cosines are not important for your grade 10th examination point of view, but you can apply these law in your competitive exams in solving difficult questions. Let's practice few questions to brush up our concept what we have understand. So very first question is, if the value of cos A is equal to 4 by 5, then the value of tan A is. Okay, the value of cos A is given. So let's draw a right angle triangle. Let's suppose this is angle A and right angle is at B and this vertex is C. So the value of cos A is given 4 by 5. Cos A is equal to 4 by 5, and we know that cos is the ratio of base and hypotenuse. So for angle A, base will be 4 units and hypotenuse will be 5 units. So using Pythagoras theorem, you will find the length of side BC. So according to Pythagoras theorem, we know that AC square is equal to AB square plus of BC square. Okay, AC is 5, so 5 square is equal to 4 square plus of BC square. So on solving, we will get BC is equal to 25 minus 16, that means 9, and we'll find the square root of 9. So the length of BC will be 3 units. Okay, so this BC is equal to 3 units. Now what we have to find? We have to find the value of tan A. Okay, so tan is a ratio of perpendicular and base. Perpendicular is a side opposite to theta, that means 3, and base is side adjacent to angle A, that means 4. The value of tan A is 3 by 4, that means option B is correct.